Hello everyone and welcome to Google Cloud OnBoard. My name is Ify and I'm an instructor for Google Cloud. Today we will be talking about Module 3, Real-Time Dashboard. At any time during our live sessions, you can ask questions on our platform and our team is standing by to answer them. So let's get started. So we're going to talk about the real-time dashboards, and that's with PubSub, Dataflow, and Data Studio. All right, and of course, we have talked about BigQuery as well. So if you want to, you can have BigQuery as well. But of course, you guys know what's a BigQuery, and let's show something else. All right, so what's the modern data pipeline challenges we're going to show you, and then we'll talk about some message-oriented architecture. That's basically getting those data comes in. All right, and then later on we will have the serverless data pipeline, which is actually using an open source called Apache Beam. And it's actually going to run on Google Cloud platforms, and it will give you the good reason why you want to run that open source here. And of course, the data visualizations with the Data Studio is a nice thing to do as well, and then we will introduce that. Okay, so what's the modern big data pipeline that kind of challenges? If you talk about big data, you always know there's this 3V. What is the varieties, volumes, and the velocities? And these are the very common things, and then you know it for a long time if you deal with data. And then these are a lot of challenge, because when the size get bigger, some traditional tools starting to slow down a little bit, and then when the velocity is changing, for example, it's not batch but streaming. Oh, there's a lot of different things you need to take in care. So, for example, we said IoT device present new challenges to data ingestion. For example, right? Because now we have data streaming from various process or devices, and then we have distributing events, notifications, and then we have to scale to handle the volume, and then of course at the same time have to be reliable. So, for example, just like the IoT things here, that just basically bring us a lot of challenge, because things are changing, huge volumes, and then when something scales, oh, that's something you need to do. And then also reliability is also important, because you always wanted to make sure that you will be able to take in care those loading. And even at the same time, when you deal with big data, single point failure happens, you still need to deal with them. So what's the architecture here? What we're going to do is use this one called Cloud PubSub. So Cloud PubSub basically will actually going to take in care the first step of your stream data processing. What is that? First, it's reliable. It is reliable. And this is exactly the one that we use it for our applications. Okay, so it's real-time messaging, and it's global again, all right? Because here at Google, yes, we do believe all our customers, they are just the same as what we wanted to achieve, to do things in a global scale. So if you do want to, yes, PubSub is global scale. And again, although everything global by default, yes, you can use it for regional as well. Why not, right? It's just about the technology able to take in care of that scale. And anything, yes, even a regional market, you might have a huge number already, okay? So this is a nice tool you can do. So what we do, what we give it to you here with the PubSub, it's at least once delivery, which is a guarantee that it's a service. So basically, PubSub, I would say like a platform as a service or even a software as a service, because we basically give you a guarantee that at least once delivery. And when you're working with data flow, you will get exactly once processing, because you know that is at least once. That means maybe duplicate, maybe 2 times, maybe 3 times, maybe 4 times. Those duplicate message, that means at least once, right? So you actually want the exactly once, because when you do a count, if you have duplicate, come on, the number will be changed, right? So you want exactly once. So that's why we said you want to have that combination with data flow. And this one, no provision, automatically for everything. Yes, no provision. you don't need to go and tell us that now you're going to have an event and then now you're going to have a lot of message comes in, that kind of stuff. No, you don't need to tell us, because by default, based on what I checked from our documents like weeks ago, it tells us, 2,000 megabytes per second. That's the bandwidth you get by default. Wow, that's a lot. And we kind of believe, yes, that's a size for our customers. And if you need more than that, yes, if you do need more than that, of course, tell us. But most of the time, I'll say that's way enough. And we don't charge based on how much resource we give it to you, but based on how much data you comes in. So how much you actually use. So this one is an open API, and then it's global by default, and end-to-end is all encrypted. All right, so cloud serverless big data pipelines here is first ingest the data to store them, so that will be here in PubSub. So PubSub here is the one to taking care of the ingestions. Although we said it's store, yes, we were going to keep your data, but we're not going to keep them forever. No, it's not. By default, we keep them 7 days. But if you do want to keep them a little bit more, yes, you can do that. But then you will pay for the storage price. And then once you get the message, you're able to capture all those information, all those user behavior, then you go for processing. And that's go for data flow. So later on, you also see BigQuery that supports some ad hoc queries, and then you have some visualizations. Okay, so let's go with the scenario, for example, an HR messaging system. For example, wow, boom, we have a new hire event. So there's a topic here in the PubSub, which is the HR topics. And now we have a new event, which might coming from HR systems or coming from a vendor office. And there are some decoupled sources, and they all send a message to PubSub, to the same topics. Okay, because they are all same kind of information. So they go to the same topics. And then who actually waiting for those information coming from the HR system or the vendor office? For example, here, you might have a lot of different systems actually need to use those messages coming in. So here have a PubSub in between. It's just nice because you can easily to decouple. You don't need to like having all the underlying system to all links to the HR system or to the vendor office. No, they just all connect to PubSub, and that simplifies your architectures because everyone took to PubSub, and PubSub is always available. And it is a huge system under the scene. So that is able to taking care of the fault tolerance, and then you will not feel it. So here, make things super simple, and having the PubSub, which is a message bus in between, you just easily decoupled your publisher and your subscribers. So in this case, both sides scales better. Again, right? We keep mentioning scaling is a very important thing here. And having a PubSub, then you'll be able to run a decoupled systems. So in this case, yes, your source, your publisher, it's decoupled from the sender. So even the publisher having some issue, doesn't matter, PubSub's there waiting for it. And then even your subscriber, which is those under-scene workers having some issues, doesn't matter because all the message will be just right there in PubSub waiting for you to actually process them. So basically at the end, what it looks like, you will have a lot of system and all talks the middle, which is the PubSub. So that's a nice message delivery system, and which is called a message-oriented architectures. So what about the serverless data pipeline here? We do need to taking care of something here, which is processing them. And then we need to have a pipeline design. So we need to solve two distinct problems for the pipeline design and the implementations. So for example here, will my code work with both batch and streaming data? Oh, that's actually one good question, because before, what we always do, that's what I've done before. You have streaming pipelines, and then you have another one which is called batch pipeline, which is more for your archive to make sure you always get the data. Because the stream one, sometimes you might lose some of the data or it's not able to catch up with the speed. So you will have the batch as a backup, or you just have two pipelines, which is one batch and one streaming. And second, does the SDK support the transformation I need to do? Yes. So this is also one of the good questions because different kind of platform, different kind of framework support different kind of way for you to define your transformations. That means to change the format of the data, or basically I would say changing the stage of your data, coming from the raw message to become something intermediate, and then you can move on to do analytics, right? And are there existing solutions? So the answer is yes, likely choose from template. And that's answered by Apache Beam, which is the open source. All right, so you can actually start with those provided template and build from there. So we actually have a lot of existing codes for you because those are the ones that we built it as a template that you don't really need to do the coding by yourself, but a lot of things we just know that these are the common scenarios, so you might want to go for it. For example, you have some real-time message comes in, and then you just want simply have them land into BigQuery, and then you can start to use the standard SQL to analyze them. And then once you maybe wanted to do, that's the load, right? So load streaming data into BigQuery, and then you do some processing, that's the E, which is the extract. So you have the ELT or LET. Okay, so many kind of ways you can do. Okay, so in that case, yes, you will be able to process all those things in the BigQuery, and then furthermore, you can go for the analytics, go for machine learning, and I've told you already. All right, so what is Apache Beam? So Beam is an advanced unified portable data processing programming model, and this programming model, yes, this is the place that give you all the ability to define how you wanted to process your data. Okay, how to process your data. And then we have the programming models, we have the SDKs to write those data pipelines, and then runners to run distributed processings. So again, this is an open source and it's from Apache, yes. And it supports a lot of things. And when we talk about the runner, that means this is an open source that you define those high-level logics that which is very close to human language. It's not exactly a SQL, but it's actually something very similar. So you can easily to define what you actually wanted to do with your data with a very high-level language. And then once you're done with that, Apache Beam are able to run on different platforms. For examples, when we say a lot of those parallel computing framework, in your mind, what comes into it? For example, MapReduce, or maybe Spark, or maybe even something more streaming like a Flink. All right, so those are the kind of like common things, and then they are all kinds of options for you to run your Apache Beam code. So this one is more like an API level on top. You can easily to define what you wanted to do, but what actually taking care, what happens under the scene to processing those data, it is taken care of by those parallel computing frameworks. Okay, so Apache Beam itself here, you have the user code, and then you can having a lot of libraries to do the transformations, and of course to having a lot of I/O coming from different kind of source. You have some message, you have some database, you have some different kind of files, and then you have some SDK for different languages. So we do support Java and Python. Okay, and by the way, Apache Beam at the very beginning, it's only Java. So still, Java have better performance and then have a little bit more options for any kind of like I/O, which is input and output. Okay, but if you do just wanted to do here on Google Cloud Platforms, we are working very, very intense to actually to spend more time to expand the possibility to using Python. So if you do want to use Python, go for it. But of course, check the documents before you make the decision. And then of course here, we said Beam model representations. Yes, exactly. And then the runner, you can run on Spark, on Flink. Or the third one, it's Dataflow. So what's Dataflow? So basically, I would say you are not writing codes for Dataflow because you are actually running open source APIs, okay? Because we have a lot of questions coming to say, hey, why I will write a code which is only able to run on data flow? It's not. Because those code you are writing, they are actually Apache Beam. They are open source API. They can run everywhere. Even you can run on a Spark cluster by your data proc. Okay. Oh, by the way, now we have some pop-up of the questions. If you do have some time, go for it. I might going to remind you later, okay, but go for it, and then I will answer them later on. Okay, so yes, data flow, this one, you are writing Apache Beam code, but you can easily just choose data flow as the execution environment. So let's see, here's a pseudocode. When you do Apache Beam code, it's pretty simple. You create pipelines. Yes, this is what you wanted to do. You have a pipeline here to define what's the data source and then what kind of transformations you wanted to do. For example, you want to do some filtering, you do some groupings, you do some transformations, and then where's the output? So if you've done data pipeline before, you know what you're actually trying to do here is create a graph. Or you can set create a sink, because when the water goes by, yes, you use a sink to kind of do the transformations. Okay, so that's how it works. And on the right hand side, there are some pseudocodes. For example, when you want to do some filtering. Okay, that's more like a map reduce things. Good. So that's the one. And that Apache Beam code, you can use exactly the same codes, which is, those transformations to apply to real-time data or batch data at the same time. And this is simply amazing me. Oh, really? I love that. Really. I've done streaming things like before, and then it's quite common. You have a streaming pipeline, and then you have batch pipeline. And then, for example, what a common one for all the open source, for example, you have Kafka, Spark Streaming, Elasticsearch, and then Kibana. That's quite a common one. And I've done that before, but I'll say this one just makes things so easy. Because first, PubSub itself is no longer just a platform and you don't need to maintain it. And it's a full managed one, and you can easily choose taking care all the kind of scale because you don't need to provision. And then it's just simply easy to just capture every single message. And then after that, you will just easily use data flow, and then now you get a very high level kind of language, which is Apache Beam, and which is also portable if you wanted to move between different platforms. And now you get a nice option here, which is data flow, to able to run that easily. And they have a full integration with PubSub, and that brings you exactly once processing when you have PubSub and data flow combined together. But other than that, those codes that you write in Apache Beam is actually able to apply to real-time and batch data at the same time. Or even you have some real-time data comes in, you want to reference some of the data in batch. For example, you have some data in cloud storage, you wanted to do some referencing. Are you able to do that? Yes. Yes, you can do that. And then once you're done with those calculations, you can right now having some output into BigQuery in real time. Then you can do some real-time APAC queries. Yes, you can do that. Or you can just trigger something in the PubSub. Or at the same time, you can having some archive back to cloud storage. That's gonna happen. And here you can have all of them in the same place, write the same codes, and deal with real-time batch, and having the real-time dashboard, trigger something, and have the archive all at the same time. All right. So now data engineer need to solve those two distinct problems, right? So still, the implementation. How much maintenance overhead is involved? Is the infrastructure reliable? How is it calling handled? So the scaling, how it works. So how can I monitor and alert? Am I logged into a vendor? So basically it's not, right? So how many maintenance you need to do? So I'll say in data flow, you don't taking care of the cluster. The cluster creation is by the data flow itself. You only write the job and you submit to the data flow, and then data flow help you to create a cluster and then help you to even to check how much data you have and then do the auto scaling for you if you enable that feature. And then if you build on Google infrastructure, of course it is reliable. And then we're taking care of those fault tolerance kind of things. And then the auto scaling works nicely. So that's also taken care of by us. And of course, we're taking care of those integrations with stack drivers, so you can easily to monitor and then having some alert. Oh, by the way, the questions is going to disappear soon. So if you haven't answered yet, go answer it. All right, it's okay if you get it wrong. If you get it right, that's nice. If you get it wrong, doesn't matter. Just give it a try. So now what I said, if I log into a specific vendor, I mean, of course not. It's open source. Apache Beam, it's an open source. It's run everywhere. And you can even at Google, you can choose Dataflow or even run it in Dataprop. But I'll say, of course, if you do a streaming with Dataflow, because Dataflow help you to taking care of the streaming auto scalings, all right? So Dataflow does ingest, transform, and load, and then taking care of those filtering and taking care of the grouping, and even for the windowing when you deal with streaming data, okay? Even deal with the streamings with the window using the streaming data, and that's a very important thing. So then why serverless? Of course, I mean here, once you start to use, if you run a cluster by yourself, you need to do the resource provisioning, handling the growth, reliability, monitoring, even to do a little bit tuning. But I mean, if you do it here, for example, using Dataflow, you just focus on the code on Apache Beam, and then when you start to submit the job, you just point it to your Dataflow. Okay, just point it to the project and then send it to Dataflow, and Dataflow taking care of that for you. So you only focus on the programming, which is the one really brings you the values. Okay, so we said example data for fully managed workflow is here. You have some Apache Beam code, you submit to the Dataflow, and then we will execute the job, and then you see with a whole bunch of modules here to help you to taking care of a lot of things, like read some data and then having some output back. And then here, instead of just getting those compute and storage, what we get? First, because you are running on a distributed environment, you actually design a graph, which is the data pipelines, and then you will run the graph later. And of course, there's some lazy evaluations in between, and for that, we have a graph optimizer to help you to optimize for you to run your codes on a distributed environment. So that one, yes, we do. Every parallel computing framework, they do it as well. And then second, work scheduler. When there are a lot of work comes in, how to schedule this job, or even auto scaler. And one of my favorite is dynamic work rebalancer, because when a streaming job comes in, what will happen? Sometimes more, sometimes less. And then when there's more, what do you get? You get more nodes, and then when those more nodes, they are new, and then no job assigned to it, right? So what do you have to do? Very simple. Dynamic work rebalancer, just get all those existing jobs, which is they are running already. They will put them back and then do the calculations and then evenly distribute them back to all the workers. So always you'll be easy to utilize all those resources. And that's simply amazing. I do suggest, if you do guys interested about that part, we have a lot of big data posts in our blogs, and then you can go for it. Just look at dynamic work rebalancer with Dataflow. Of course, and then now we have the watermarking. That's a very important thing to deal with streaming data, and then have auto hailing, monitoring, and loggings. So Cloud Dataflow, it's serverless, it's full managed, and it's really a nice place to taking care of streaming data processing. Of course, batch is also good, but I'll say streaming really shows the strength of our Dataflow. And then it's running open source programming models, and then it's intelligent and easy to scale. All right. So once we're done with the data ingestion with PubSub, and then now we have the data processing. Of course, now we have the Data Studio. So Data Studio is actually the one that you can easily to use, and then there's a button in our BigQuery. Once you have the result, you can click on it, and then you can just get in the result goes to Data Studio. That's nice. And then Data Studio itself, it's actually not just work for Google Cloud, but also all the kind of product coming from Google. For if you use data advertising, that kind of things before, yes, you might have seen Data Studio before because that one gives you a lot of nice charts. And then you can easily to build and collaborate and share your dashboard easily. For example, this is one of them that you can just easily build something looks nice. And it's super easy for you to share because it's just like all other Google stuff. For example, the Google Slide, the Google Docs, you can easily just click on the bottom share and then share with someone. If they get a Gmail account or they are using G Suite, very easily just share that and then grant the permission for them to check. Or if want it publicly, you can share a link to anyone. For example, give it to your users or just having that carry on and go to do your reporting. Okay. So it connects to a lot of those different type of data source, including Google Sheets, our platform in BigQuery, and then advertising, DoubleClick, and even Google Attributions 360 and Analytics 360. Wow, that's a lot. So I would say Data Studio will be a nice place that you can kind of combine everything that's coming from Google and then have a central place to actually make those visualizations. All right, so that's a very nice place to actually taking care. And by the way, just mention a little bit that because every single query from BigQuery, there's a charge. But now we have a new feature called BI Engine. Okay, BI Engine. It is BI Engine. Okay, wow, someone amazed. So BI Engine is the one actually give you a cache on top of BigQuery. And then that really supports the Data Studio. So basically, most of the time, when you query anything, you do any changes on the Data Studio, you actually go for the cache first instead of going to do a query in BigQuery. So in that case, you kind of save a lot of budget because it's no longer every single time you change something on the dashboard, which is in the report in Data Studio, it goes to do a query in BigQuery, but actually go for a cache first. And of course, if you do something changes, then the cache have to be refreshed. So then at that time, yes, there's a query goes to BigQuery and they might have a charge. Okay, so by the way, a little bit more best practice because BigQuery, you have a raw data, intermediate data, and then those data marked for the business user. So I would say having those data marked to create the reports. And then, of course, using BI engines, then you will get the cache for those data marked. All right, good. So create chart and visualize data relationship and then share and collaboration on those dashboards. Okay, so this is exactly the way you're gonna do. All right, so now we still have a little bit of time. Let's go for the live questions. So please select the common cases of Google Cloud pops up. So what's the case? Oh, yeah, the answer still again is the all of the above. Okay, still all of the above. I hope you guys answer correctly. You see, this one is just tells you every single detail that you can do here with pops up. All right, the second questions. What is correct about Google Cloud Data Flow? All right, so you actually see a whole bunch of these nice statements there. I basically copy paste from our documents and then you get the answer, which is all of the above. I mean, seriously, data flow is simply nice and easy, and it is really designed to taking care of those batch and stream at the same time and make things really easier. Okay, so again, thank you for joining our digital event. Please stay tuned for our next module.